Hello, friend. My name is Derek Carter, and in the video today, I'm going to be walking you through an example workflow for a practice assignment. Okay, so this video is meant for many different kinds of classes. But in these classes, you might be asked to do an assignment in like maybe C++ or Python or something like that. And it's going to be set up so that you need to use Visual Studio Code with what are known as dev containers in order to create commits and push them to have them graded. Okay, so hopefully the purpose of this video is, like, we don't expect people to be familiar with these tools, so we want you to learn the basics of how you can use VS Code and dev containers, and what you need to do in order to do the typical workflow for these types of assignments for the class. Okay, so if you're ready, then let's go ahead and get started. Just a quick note. So I assume that you've already gotten your environment set up. Okay, so we're not going to cover that again in this video. So you need to have your Git, Docker, and VS Code already set up. Have a GitHub account created and Git installed and working. You need to have Docker desktop installed and the engine running, and you need to have VS Code. Okay, so usually for my classes, if you're in one of my classes, I'll have like a getting started, and there should be a link there. So I'm talking about these first instructions. So currently when I'm doing this video, it's this URL here that you can use to follow the instructions to get your Docker, Git, and GitHub accounts and VS Code all set. Okay, so if you haven't done that yet, go do that first. All right, and there's a video as well that you can watch in order to get some help getting that set up. Okay, in this video though, I'm going to be looking at these things. I'm going to maybe go a little bit quickly through these, but like I said, we want to give you an idea of we don't expect you to be familiar with these environments beforehand, but give you a chance to practice these. Okay, so I'm going to start by looking at accepting the assignment, accepting the GitHub assignment here. Okay, so the first step for an assignment is there should be what's known as an invitation link. Okay, so I'm going to find the invitation link for this practice assignment 0 here. Okay, so when you click on this, the first time you see this, it should ask you to associate your GitHub account with the name in my gradebook. Okay, so if you don't see that, or if it gives you a list of names, you don't see your name on there, stop immediately and let us know. Okay, so it means that you're not in the grade book. So it might just be that you got left out, but it could mean that you're not registered for the course. Okay, so once you select your name, the second thing you'll see is to accept this assignment. So you should go ahead and accept the assignment. This basically creates a repository on GitHub that I actually own it, but you have read-write access to it. Okay, so once you've created it, you can click on the link that it gives you here in order to go to your repository. It'll be named something like with the name of the assignment, and then this will be whatever your GitHub ID is. Okay, a note, I see a lot of people, you can go back and click on the invitation link. It'll know that you already accepted it and give you the link to go back to the repository. Or alternatively, you can just go to your GitHub account. And if you look under your organizations, so basically my organization owns this. So in this video, I'm using an organization called 430 Operating System Summer 2025 here. Okay, so but if you look at your organization, in there you'll find a repository. That's another way you can get to it if you don't want to log back into my Leo Online. All right. Okay, so now that you've accepted the assignment and we've got the repository created, the next step here is we want to clone the assignment repository and open it up in a dev container. Okay, so to do that, what you need is on your home page here, so on the code page, look for the green code button in GitHub. Okay, so this thing right here, right? So this, if you pull it down, you'll find the URL that you need to clone your repository. Okay, so make certain you need to use the SSH one. So HTTPS only allows you to, download and read a repository, but you need to have read-write, right? And you have to have your secure shell key set up in order to do this correctly, to use the SSH URL. Okay, so go ahead and copy that. So once you've copied the secure shell URL, go ahead and open up your VS Code. So there's multiple ways that you can clone your repository and get it open in a container. I'm going to show, the way I usually like to do it is over on the left-hand sidebar are the main things that you need, including your file explorer, some search, how you manage your extensions. You need to have the, so this is one of the things in the previous video, you need to have the dev containers and or the remote development extension installed. So this one is an extension pack. If you install that, it'll install a bunch of others. But I think at a minimum, you need at least to have the dev containers extension. Okay, let's go ahead and clone the repository. So when you hit that, it gives you a box. So you just go ahead and paste that URL in there and hit return. So don't use the second option. Just use the first one to clone it from the URL like I just did. All right. It's going to ask you to pick a location on your host machine, on your local machine, where you want to put the working repository. Okay, so this is the code is going to get downloaded and it's going to live on your local machine, and you're going to be doing all your development down in your repository on your local machine. I always recommend having a repos directory under your home directory. That's where I usually clone and select as my repository destination to clone all of my files in here. Okay, so in VS Code, basically a directory on your file system works as like a project. So in order to do anything, you have to open up a file on your file system to work in that project or work in our project repository in this case. So you always want to open it up after it clones it here. Okay. So also let me mention, if you have Docker running, again, this is stuff from the previous video, previous instructions, and everything's running correctly, you should get an option to reopen in a container. Okay. If you don't see that, Docker might not be running, or there might be some other issue. So you have to go investigate that. If you miss that pop-up, so another way you can clone and open a container. So if you have your remote development extensions installed, you should see what's called the Remote Explorer here. So that'll be added on the left sidebar here. Okay, so in here, another way, if you miss that pop-up, but you do have Docker running, I can create a new dev container. So that was basically what it was giving me the option to do, to reopen it and create a dev container. But I can go ahead and click the plus here and open the current folder that I'm in inside of a container. Okay, so you want to do that. Okay, another thing you can do here, instead of using the source control to clone the repository, you can go to the Remote Explorer for the dev containers, and you can do a clone repository in a container value. So some people like to do it that way. But I already cloned it, so I'm just going to open my current folder in a container. So this might take some time. So this is going to actually create a Docker container for you. Okay, so the very first time you do this, this will take some time. All right, I've already done this before, so I actually already had a bunch of stuff downloading things. Also, you'll often get a message about there's task errors. You can ignore that. It's just being a little bit too quick. Okay, so but later on it'll figure out there's actually no task errors once it figures out the correct mode for IntelliSense and some other stuff. Okay, so now that we're actually successfully running, we've got the assignment created, we cloned it, and we reopened it in a container. So so I've already been talking a little bit about using VS Code, but let's I can say a few more things about using VS Code at this point. So here, so one thing to check, you can tell whether you're in a container or not. Let me make that a little bit bigger so you can see. You'll get an indication here that the folder, my project, is in a dev container. Another place you can check is down the lower bottom. There's a bunch of status down here, lower left-hand side. So here I can also tell that I'm successfully running inside the dev container like I need to. All right. Yeah, so let's do a few more VS Code things. So, you've got the basic things, the most important stuff on the left-hand sidebar. So you've got your File Explorer. This allows you to see all the files in your project. A search function. This is where you go in order to make commits and push them and pull them. The source control. The debugger, which I'll cover later. The Remote Explorer for working with your dev containers, manage them so you can create and delete them here. The extension manager for all the extensions. So one thing I should note is we install the extensions inside the dev container that you need. Okay, so this is a C++ project, so we've installed C++, extension pack, and we've installed a test runner for you. So those are already in there. And the test runner can be run from over here on the testing timer. Also, I won't cover it, but down here on the gear, there's a lot of important stuff, including settings. You can get to the full command palette. So everything you can do in VS Code, you can access through the command palette. And there's other things over here, including, for example, if you want to change to using like a dark theme or something, you can select your theme and do other stuff like that. All right. So. And one other thing before I move on, something about VS Code. So you're gonna in the classes that these videos are meant for, you're gonna have to do some stuff from the command line, right? So if you've ever done that, you'll get to learn how to do some things like that. So if you go to terminal and open up a new terminal here, you'll get it down here on this, what they call a panel. That you can expand or not, right? So notice, you may not be able to tell, but this is actually running inside the container. So for example, in this video, we're using a container that's actually running Ubuntu, even though my host system is a Windows system, right? Another thing, so we might want to check, right? So this is another thing from a previous video, but I might want to check that I'm able to successfully authenticate with GitHub. Right? So if you do an SSH to git@github.com, it should be able to successfully connect to Git using Secure Shell, and you should get a successful authentication method. Okay? So some people have problems with this. If it's working on your host system, but when you get inside of a container, you get an access denied, probably your Secure Shell agent isn't working correctly, right? So there was some help or information about getting your SSH agent set up so that your Secure Shell keys are inside the container that you need. Okay, with that, let's go ahead and actually get into working on the assignment. Okay, so we'll look at the practice assignment here and work on kind of the standard workflow that you would do for assignments for this class. Before we do that, there's a couple of things you should always check out before you try to jump to working on the first task. Okay, so going back to my repository, the instructions for the assignment are going to be in the README, so they're going to be on the main page of your assignment here, right? So there'll be the description, there'll be the overview and setup, and then somewhere down there will be the actual task 1, 2, 3, 4 that you have to do on the assignment. So you won't always get this, but there are a couple of things that you should check before you start working on the assignment tasks. We've already cloned the repository, and we're able to connect with SSH inside of our container, and we're running inside the container. You should always check that the initial project compiles and runs. Okay, so this may not be for all classes that this video is meant for, but if you're doing something where we use a compiled language like C, C++, there's going to be a standard build procedure, make build, make tests, that needs to be done while you're working on the assignment. So initially, your assignment should be building and running cleanly. Okay, so for C++ projects, you should be able to do a make clean. So if you open up your terminal again and go to the command line, make clean just deletes a bunch of stuff and makes certain that everything is in a clean state. Okay, so it just does a bunch of removes so that when we do a build of everything, we know that everything's being built cleanly from scratch. Okay. Bigger maybe. So then the next step usually is to do a make all. Usually the make all target is the default target. So if you don't specify a target for make, it will do the build everything, the make all by default. Okay. So you should not see any errors or problems here. If you see an error before starting on the assignment, let the instructors know, because the assignment should always be in a buildable and runnable state when you start working on it. Right? So this is an example of it compiled, did a bunch of compilations to object files, made a couple of executables, and there were no error messages or link errors when we compiled the code here. And then finally, you're going to have to be doing unit tests. So each task, there's a bunch of tests that you need to pass before the task is complete. So you want to check those out. But for a lot of assignments, there won't be any unit tests initially, so there won't be any test to run. And if you go look at your test runner, you'll see that there's no tests found yet until we enable some tests here. Okay, so if you don't like jump down to the command line and type your stuff out to build your projects, usually there should be a extension, some kind of task runner. At the moment, I'm using this one because it works for these easy kinds of projects fairly well. So for example, to use this one, if you don't see this one, you can install it or look for, there's other task runners. There's a bunch of different implementations of these. This particular one, if this is the one that I gave you to use, you'll find it under the file, the Explorer section. You'll see the task runner. It should automatically pick up the predefined tasks for the project. So you can also go from there to do your make clean, make all. And then, yeah, I think there's a bug on this. So like if you don't have like a file open here, you'll get an error on that. So make clean, yeah. So I think if there's not a file open, it's a problem on that. But those should work. Make all, and then make unit test. Okay. And then finally for building here, like I showed in the instructions for the practice assignment, I mean, if you really want to get productive, I usually use keyboard shortcuts for that. So they won't be installed by default. So if you want to, there's some example shortcuts that I usually use. You'll find it under the VS Code, under the key bindings here, but unfortunately it won't install those automatically for you. So I usually use Control-Shift-C to do a make clean, Control-Shift-B to do, that'll do the make all, and Control-Shift-T will then run the unit test. You can copy that and use that for your own key bindings or use some different key bindings if you want to. To change your key bindings, you have to go to the gear and look for the keyboard shortcuts. And you could, it's got a GUI that you could add these in by hand, but I usually just open up the, I just usually up here on the upper right, open up the .json file and paste in those key bindings. So once you have those in, I should be able to do a Control-Shift-C. We'll do a make clean. So we did the make clean there. Control-Shift-B is those key bindings have that will do the make all, build everything, and then Control-Shift-T will run the tests. Okay, so if all that's working, you're ready to begin on the actual assignment task, okay? So, so what we've looked at so far in the video, we've accepted the invitation from GitHub to create the assignment. We've cloned the repository and we reopened it in a dev container. We made certain that we were running the dev container and that we had secure shell connectivity inside of our container. And we just showed confirming that the project builds and runs, although we don't have any tests actually defined and running at this point. I do encourage people to use the what are known as tasks. So let's go ahead and create our task 1 before starting it. So these are called issues. So this is a normal thing when you're doing GitHub projects or any kind of revision control online. So for our assignments, you should have templates for you for these issues. So let's get started on task 1 by doing the new issue and create it. Okay. So this will be kind of a too long, don't read description of the task 1. So a summary of the stuff that you get in the larger instructions on the README. Okay. So I'll go ahead and create my task 1 instruction. And I'm going to go ahead and associate it with my pull request. So we'll come back and talk about this pull request here real quickly, but I'm going to go ahead and go to my feedback pull request and link my task 1 with my feedback pull request here. All right, so it should eventually show up that I'm now working on task 1. Okay, so with that, we're actually ready to work on the assignment task. Okay, so let's go to our practice assignment. So this is a little bit more specific. You may not be doing C++ assignments, but there should be a similar kind of workflow. And I'll be going over, like creating commits and pushing them and stuff like that on this section here. So let's go back. So our first task in this assignment is we need to implement a function called isPrime and get it working. Okay. So the very first thing you do when starting on a task is you want to enable the tests for that task. So so for these assignments, these are multi-file assignments, okay? So, if we're over here looking at the File Explorer, you'll see that there's a bunch of files, a bunch of subdirectories, actually. So we've got like an include subdirectory, a source subdirectory, and others in here, okay? So in particular, let's look at the include and the source. So most of the stuff you'll be doing on the assignments are going to be in the source or the include subdirectory, where there's files that you have to add code and implement the task. Okay? So to get started, there should usually be a file called something-tests. So that will have the tests in it that you need to enable and pass in order to successfully, get a task working for an assignment. So in this case, we've got 2 tasks for this practice assignment. You should always do them in order. So we need to start with task 1. So the first thing you do is you need to enable the tests for a task by changing the undef to be defined. Right? So you see, as soon as I save this, that Visual Studio Code notices that this if def is now defined, right? So these are not all enabled. Right? So let's go ahead and do like a build here, see what happens, right? So now if I do like a make all, you'll see we get errors now, right? So this is what I talked about. If you do a build before you start the assignment, you see some errors, let the instructors know. But here we're having errors because we're supposed to write a function called isPrime, and we haven't actually written that function yet. Okay. So for these types of assignments, what you have to do usually is in C++, which is a compiled language, when we're doing it with multiple files, we're going to have what are known as function prototypes or function signatures are going to be in the header file. So other files will include the header file if they want to use the isPrime function, okay? So the first thing that we need to do for a task for these kind of assignments is we need to declare our function in the primes.hpp file. So let's go ahead and open up the primes.hpp header file, and let's put our function prototype in. right? So this is just basically saying somebody somewhere is going to implement a function called isPrime that takes an integer as input and returns a Boolean result. Okay? And in C++, a signature you end with a semicolon instead of having open and closing curly braces, which is where you put the code for an actual implementation. But we're not implementing it in the header file. We're just declaring our function. Make certain you always save your files when you're working on them. But that is what we, if we go back to the test, that is what we're including, the include primes.hpp. So now there's somebody somewhere that says, okay, somebody's implementing a function called isPrime that takes an integer and returns a Boolean, right? So that's enough information for this file to actually compile, because it doesn't implement it. It's just trying to use this function. So let's rebuild it, right? And you'll see that the assignment tests actually build, but we're still getting errors. Okay, so we get link errors because we haven't actually implemented the function yet. So it's undefined. Okay, so we have to actually add the implementation. So this, we're only going to create a stub function. Okay, so our goal right now is just to get enough code so that we get the project back to a compilable and runnable state. Okay, so never add a bunch of code when your project is not compiling. As soon as you know that your project is not compiling, you should stop and fix it so it's back to a compilable state and you can run your tests. Okay? So I just want a stub function that will be enough to actually allow my project to compile and run, right? So we've got the declaration of the function. So all of the implementations of your function should go into a .cpp file, right? So our implementations of our primes library goes into the primes.cpp file. And in this case, you should always have function documentation if you're doing projects for me, for my classes. So this is the actual documentation for the function that we're going to write here. But this function really doesn't do anything yet. It just always returns true, right? But that should be enough to get the project to compile, right? So for these tests, it's going to always just return true. So that's not correct, right? So 4 is not a prime number. So it should be returning false, right? But this should be enough to, so I can do make all and check, make certain that everything's building, right? So everything built now. So now we're actually ready, so we're getting up to this part. We're showing how to compile and test our tasks here in the assignments, all right? So we just compiled it successfully. So let's see if the tests run. So like we did from the command line before, we could just do the make unit tests, right? And you can see that something happened, although the test failed. Once you have a test defined, you should also have the test runner should now actually be available, okay? So this won't be valid until some tests are actually defined and available. But now that we enabled a test, we can look in here and we can run our test from the test runner. This will do the same thing that running the make unit test did here. So let's go ahead and run it from there. So this will give you a little bit more information so we can actually click on here and find the location where the tests are failing. So it's actually failing a lot of places. But this shouldn't be surprising. So every place where it's supposed to return a false, for numbers that are not prime, it's failing. Okay, so we don't have task 1 working yet, but let's go ahead and look at making a commit and pushing it so we can so I can see it and evaluate it and grade it for you. Okay? So anytime you've made a significant accomplishment when working on an assignment or any kind of a Git project, you should make a commit and get it pushed up there. So the motto is to push to commit early and push often whenever you're working on projects like this. All right. So to make a commit, we'll go over here to the left-hand side to the source control here. Okay, so this is how you access Git or whatever revision control system that you're using. So at the moment, ignore the dev container, you shouldn't see that. So what I was showing you guys so far, we made changes to, we started out by making changes to the assignment test. So if we click on that, you'll see what's known as a diff. Right, so we see that I basically, the only thing I can see on the right-hand side, that there's no other change in this file except for right here. There's only one diff. So we changed this line from undef to define. Right? Likewise, there's just one line that changed here. We added a line on our primes.hpp. And then we added in our stub functions to the prime.hpp. Okay? So I want to do what's known as staging these three files. You first have to say, okay, which files do I want to put into a commit, a new commit that I'm creating. So I'm going to go ahead and stage these three. Be careful. So only stage the ones that you actually made changes on, right? So never just hit the plus at the top to stage everything. If there's stuff in there that isn't really part of the commit you're making. But, before I make the commit, I can, if I made a mistake, I can, excuse me, I can put that back out of my stage changes here, right? So these are the only three things that I want to make a commit of. Another thing, so best practice is you should always have commit messages that have a title, and then a longer description. I'll give a link in the repository for this about best practices for commit messages. In this case, so far, we've created like the task1 stub function. So we created a stub function for task1 that compiles and runs tests, but our tests are not all passing yet. Just as a quick example, right? So here, to get a title, you have to have a blank line between that and then your description. So once you're satisfied with that, we can hit the commit button. That will actually create a commit. So notice here on the graph, we see our new commit here at the top of the other previous commits that have been made on this repository, this project here. But once you did the commit, it's still local to your machine. I can't see it yet. So now you actually have to push the commit. So sometimes you'll get a message. I don't know why it doesn't always show up. A message saying, do you want to go ahead and push your commits? If you don't see that, you can always use these buttons here or again down here on the status. So another word about Visual Studio Code. So there's some more status down here about your Git or about your source control. So we're on the main branch. There are 0 commits that are on my repository on GitHub that I haven't pulled down yet, but there is one local commit that's not on GitHub yet that's waiting to be pushed up. So I'm just going to push that down there. That should push the commit up to GitHub. Okay? So if we go back and look at GitHub, so you'll see that you can look at your commits like here on the code page. You should see it there. Or let's go ahead and look at the feedback pull request. So this is the main thing that I look at when I'm working and grading and evaluating your assignments. Okay, so if it doesn't show up here, if I don't see the commit here in your feedback pull request, I probably haven't seen it yet. I can't see your work to evaluate and grade it, and you're still getting a 0. You haven't really completed that task yet, right? So notice, here's my commit with my title and my message. Furthermore, these things that are known as GitHub Actions, this will run the same test, okay? So you probably always want to check these, go here and view the details. You should see the same results that you saw when you ran your test locally, okay? So it'll always first test that your build is running, is compiling successfully or not, right? So for these assignments, you'll get a 0 if your code that I'm evaluating is not building, right? So it always needs to successfully build before I can evaluate it. And it's a 0 if it's not building, okay? But after that, you'll get partial points for each task that you complete. And again, this should be exactly the same. If I go back and look at my task 1 tests here, or if I go ahead and rerun my make unit test so I can see the output. So this should be the same output you'll see on VSCode, that when it ran the tests for task 1, it's failing the one on line 46 and 50 and so on. And that's what we're getting here in the autograder. Okay? But always check that. Okay? All right, so so that was some things about the feedback pull request then. So let's finish up this assignment. So let's finish up task 1 and see what it looks like when you actually push a commit that's actually passing your tests. Okay. Okay, so let's go ahead and get task 1 completed, so it's actually passing our tests. All right. So for this practice assignment, we gave you a brute force solution. So we go down here, reading instructions for task 1. There is some example code that basically, just real quick, so a number is prime if it's only divisible by 1 in itself, right? So this checks every possible number from 2 up to 1 minus the value, and if it finds any one that that's divisible, then the answer is false. It's not a prime number. Otherwise, if we don't find one, then the answer is true. It tests out to be a prime. Let's copy that solution and see if it actually works here. Okay, so I need to go back to my primes.cpp file, and instead of our stub, we need a working solution. Oops. Using this brute force loop here. All right. So let me go ahead and do like a clean build here. So let's do a make clean just to make certain that we rebuild everything from scratch. Make all. Make certain that it's actually compiling and we're not getting any compilation errors here. And then let me go and use the test runner to try rerunning it. So this is what you want to see, right? So green check mark. So that means that when we ran that, we've only got 1 test enabled so far, but when we ran it, everything worked, right? So, and again, if we double click on this and go back, we'll see that there's no markup anymore from the test runner, right? So all these tests, and we're getting the green check mark there as well. So all these tests ran and actually passed. Okay? That's significant. So let's practice making a commit and pushing it again. So notice the only thing I changed on that session since the last commit was I deleted, or actually I didn't. I just added this code, right? So we only had return true, but now I added in the actual implementation. So that's the only thing that's changed. So I've only got 1 file that has a difference now. So I'm going to go ahead and add that and make a commit of that. So now our task 1 is completed and passing tests. We implemented a brute force method to test all possible divisors to see if the number is prime. Right? So now we've got our good commit message. So I'll do the commit, but it's only local here. So let's go ahead and push it up. And let's go back to our feedback pull request and check if it showed up here. So yeah, there it showed up, and it's actually still running here. So we can actually watch it run in Git's action auto run. Although maybe we won't wait for it. Up, yeah, there it finished. Okay. So here, yeah, I did want to wait for it, so we can see that it built successfully. And our tests for the is prime are now passing, right? So you can see now that we're getting a green check mark for the is prime tests, right? And you can look down here that now in the autograder we're getting 75 out of 100, right? So We're getting some for building successfully. We're getting some points for that test is prime, but we still got one more task to complete. Okay, so let's go through task 2 here, but I'm just going to do this just to summarize what we just completed, okay? So to begin with, when you're ready to start on a task, the first thing we want to do, let me close everything off here, is we want to go to our tests, and we want to enable our tests for the task we're about to begin. So I'll change the undef to define. All right. So now I've got my task 2 test enabled, and I expect now, since we haven't implemented find primes, if we do like a make all, we're not building anymore, right? So I always recommend, don't jump into the task. Let's get it so it's compiling, right, and running the test. Let's get it back to a compilable state. So in this case, I do have the stub function and the function prototype, but we can kind of infer it from here. So again, this is returning a Boolean result, notice, and it should be taking 3 parameters. It takes an integer, another integer, and a Boolean as input, right? So if I wanted to, I could use that to figure out my my signature or my function prototype, right? So in this case, we've got a function called find primes that takes an integer, another integer, and a Boolean. Don't forget the semicolon at the end here. So these are going to be like the start of the range and the end of the range, and a Boolean to control whether we want to display the results or not. Okay. And let's go ahead and put the stub function in. So this still won't compile, although, since I have that in there and saved, it should be actually compiling the test, but now we're getting, we're getting some other errors here. I was wrong. So I should have looked at my assignment script. So we're actually returning an integer this time instead of a Boolean, right? So I should have looked closer there. So we're supposed to be returning an integer, which is the number of integers that we find here. So let's fix that. Try that again. So yeah, it actually does compile the test, but now we're getting the link errors. So let's go ahead and create our stub function. So I'll copy that, go back to my primes.cpp file. Here, the names that you give your parameters should match in the documentation. So I'm going to change this one, since I called it start and end and display on cout. I'm going to be consistent. So start, end, and display on cout. There, and back to here. All right. But here I hard coded it to 9 because, if we go back and look at the first test is expecting 9. But, so I can pass that one, but I won't be able to pass any of these others. All right. So let's test that. We're going to do it, make clean, and build it. So, no, we had an error there. So I was foiled by VSCode being a little bit too smart for me, so I don't want int16 type. I just want a regular int. All right, let's try building that again. All right, so if everything's working, let's try our test now. So notice we haven't run the find primes test yet. And as expected, it fails on these 2 things here because we're just hard coding it to return 9. Right? Let's go ahead and finish off this task here. So here's an example implementation. If we go back to the instructions, this function here. So that should pass if I didn't make a typo or mispaste something somewhere. So let's go ahead and rebuild. And let's try our test again then. And there we go. So once you have a task working, you should make a commit. Make certain you only commit the stuff that has the changes that are related to that task that you're finishing. So in this case, the only thing I did on my test was you should never, another thing I probably forgot to mention, you should never change anything in the test files that are given to you except to define, to enable the test for a task. Okay, so I will go back and remove any changes you make. So you have to write the code to pass the test. You can't change the tests so that they work with your code. Is the basic idea it's happening. And for the primes.cpp, we implemented the primes, and the only thing that should have changed on my header file was we added in the prototype for this new function. So let's go ahead and we've staged those. Let's go ahead and commit those. So now we have a working find. We'll commit and we'll push those up, and let's go check and see what we got now for our assignment if we look at the autograder in our feedback pull request. So here's our second task, came up here. All right, so now, so this is what I see when you're working on your assignment. So far I've done 3 pushes, 2 on task 1 and 1 on task 2. And we are still running. Oh, it failed there. I was expecting that to actually pass. Oh no, that's not true. So for this practice assignment, once you get all the tasks passing, there is one more thing to do here. You have to get the system test, but I'll talk about that in the appendix here. Right? But notice we're only given extra credit for the system test. So now I've got it building. We've got my 2 tasks are actually succeeding, and we're getting 100 out of 100 on the autograder. Okay, I'm going to do a couple of additional things. You can kind of think of this as an appendix. You should have everything to get started on the assignments, but maybe later on, if you need to do some stuff with the debugger, or I'll talk about that system test stuff here a little bit in the thing here. So first of all, just a real quick note about the code style checker formatter. So you might want to make certain that this is running in your code here. So let me just show that. So one of the tools that's in these dev containers for you is that it actually automatically runs a code style checker and formatter every time you save a file. Okay, so but I see a lot of students at times they're not using the dev containers, or they're doing something else, and they're getting code that's not formatted according to class style. Okay, so if I see code that hasn't been run through the code formatter, I might give you a comment that I'm not going to grade it until you actually run it through the code formatter. Okay, so it's your responsibility to make certain that code is formatted correctly according to class style. There really shouldn't be anything you need to do if you're using the correct environment, right? So, like for example, if I put some code x equals y with no spacing, something like that, all bunched together. The normal things is that code needs to be indented correctly. The big ones are, code has to be indented correctly. Curly braces have to be lined up. Opening one should be on a line of their own. There needs to be white space between all binary operators, other stuff like that, right? But again, you shouldn't have to worry about that too much if you're using the code style checker, right? So you shouldn't have to look for that by hand, right? So here, notice if I do a save, it reformats that code for me, right? So if if you need to check that, or if I give you a comment that your code is not indented, you need to run it through the code formatter. Go in and put some code and try and save it. And if it doesn't automatically get indented and binary operators formatted correctly, and stuff like that, then you don't have the style checker running correctly. Okay? Another quick thing, the assignment should be set up so that the debugger is set up so you can actually use it and debug your test executable or your final simulation. Okay, so let me kind of quickly show you using the VSCode debugger here. So let's say you run your tests and you're getting some errors. Okay, so my tests for the is prime are not passing anymore, and I'm not certain why. Okay, I mean, you could go inspect the code, you could go add some print statements or cout statements, but let's run the debugger and see what's happening here. Right, so we're expecting it to return false for all of these that are not prime numbers here. So to use the debugger, that's one of the things over on the left-hand side here. For this particular project, we've got two different executables that are built. So you need to select the correct one. So we're still working on our unit test. So I want to select the test executable and run it. Okay. So now that I've got that selected, we can start debugging by clicking on like there or other ways. Right? So when it first runs, it's going to stop in the main function, which is part of our test runner here. Okay, so I actually want to add a breakpoint right before my function so I can step into that. So, one way to add a breakpoint is to click over on the left-hand side, the gutter here. So notice on my debug view, we can see the list of all the breakpoints that we have and other stuff here. So I'll talk about these other things, right? So once I have the breakpoint here, I can go ahead and just continue, and it will run till it gets to my breakpoint, which is what I want, because I want to be able to step into that. Although, a caveat, so in this particular test runner, if you step into that, it's actually going to be stepping into the catch 2. So it's going to be stepping into like this check false here, right? So that might look a little bit confusing. So notice on my call stack, from main, we called a bunch of stuff in my catch2 test runner. Here is where I was trying to step into my is prime function, but when I stepped into there, it's back into the test runner. So another thing I usually do instead of trying to step into the correct thing is I go to my actual function that I want to step to, put another breakpoint there. So let's put a breakpoint here at the for loop, and then just continue until we get to that. All right. So notice that when I continued, that we'd stop there. That's where I want, right? So from my assignment tests, I was calling is prime, which I know is failing, and I'm now ready to step through my is prime, right? So I need it to return the false here. It's not. Where now, here, if you've used a debugger, we can see that these are the values of my local variable. So a value that was passed in was 4. Because we're trying to check if 4 is prime or not. And this actually has some garbage in it. So until I step into my loop, so if I do a single step, so let's step over this. So now we're in the loop. It should have ran the initializer here. So now divisor is 2. Right? So now we're checking if value divided by divisor is 0. Should return false, right? So in this case, we know value is 4 and divisor is 2, right? So that's not 0. So now we're going to check a divisor of 3, right? Or that was the only number. So we're only checking the numbers from 2 up to the value minus 1, less than the value. So we're actually only checking 2 here. We didn't check 3. That might be a bug here if I wanted to check 3. But yeah, since 2 should have been evenly divisible, right? But it wasn't, and we're actually returning true here. Did you spot the bug? So we need to be using the modulus rather than divide, right? So that was the error here. So we expected it to return false, but it didn't do that. When it checked the divisors, it's going to return true here. So we can continue stepping over on this and seeing what we get here. returned true, and it failed the test. All right. So that's the basic things. Using Debugger can be very helpful for these assignments. Before you go and edit code, make certain that you stop the debugger, or else you might have some issues. Okay, and then let's also look real quickly at for the kinds of assignments for like this one, for this class where we're doing like C++ assignments. Usually the point of the assignment is to build an actual tool, a simulation at the end. Okay, so let's look at that and actually getting the system test to pass for this practice assignment here. All right. So now at this point, I'm back to kind of clean state. All my tasks are finished, and they're all actually passing my tests here. So in a lot of assignments, once you get all the tasks done, there might be a few additional things you have to do to get the full final simulation or the full final tool working for the assignment. Okay? So there's not much to do on this one. You just have to uncomment some stuff. But let's show some structure of what these look like here. Right? So in this case, if I can remind you, let's do a make clean and a make all here. So what we're doing on this assignment when we build stuff, if you look closely, is we actually end up building two executables. So we build an executable called test, and there's another executable in this practice assignment called sim. Okay, so the tests have all the unit tests. So those are what you have to concentrate on to get all the tasks for the assignment working. But the sim, the simulation, is the actual thing that we're trying to do for the assignment usually. Right? So in this case, if you look in the source files, there's usually going to be a source file called something like assignment sim, or maybe assignment main. So here, this will have a main function, and this will usually call some of the code that you wrote while doing the task for the assignment. So in this case, the main function, this is a normal command line tool. It's meant to be run from a terminal, from a command line. Okay, so in this case, we can try and run it. So let's open up a terminal. So if we look at all the files at the top level of our project, we can see that we have all these same directories, include, source, and so on. But we've also got the sim executable and the test executable. We can try running the sim. So to run a command in a Unix Linux environment, you have to do the / in front of it, and then give the name of the command that's in your current directory. So here, when we run it, you'll see this output, and this is coming from the usage message here. All right. So basically, this is meant to be run from the command line, but it expects that we give it two parameters, a begin and an end. Right? And basically what it's supposed to do is it's supposed to call the find primes to find the primes in some range. Right? So the way I want to call this tool, so what it does is it parses the command line arguments. So it's expecting just two parameters. So let's say I want to search for prime from 1 to 1,000. I need two parameters, 1 and 1,000. That the first one on the command line will become the begin range. The second one will become the end range. Right? But in this case, so all you have to do to get the test working on this assignment is we just had it uncommented because there was no implementation of find primes before you started this assignment. But now that we have a find primes that's working, we can actually use it in our simulation and test it with our system tests. Okay, so let me go ahead and uncomment that. We need to rebuild. So I'll do it from the command line. So I'll do a make all to rebuild. So now, if I run the sim again, right? So again, I'm going to run from my command line after I built and try to find all the primes from 1 to 1,000 now. If assuming my find primes is working, find primes calls is prime. So all of the tasks in the assignment need to work for this to do something. Right? So in this case, it finds all the primes and it returns the number of primes that it found. So let's check our system tests. All right, so this one, I'll have to check. We could maybe add that as a task, but if you don't have that as a task on your task runner, you can always run these tasks from the command line. So the task to try the system test is to make system tests. So in this case, it basically is running different system tests to see if your final full simulation is passed. Okay. And again, as sometimes to get full credit for the assignment, you have to get your system test passed. So once you have them passing, we'll want to create a commit. So we'll add the change that I made here to the assignment sim to enable that function, and we will go ahead and commit that, push it up to our repository, and check if we're getting full green marks now in the autograder when we run it in our feedback pull request. So let that run for a minute. And then we're done with the autograder. So this is what you should see if you're going to get 100% on the assignment. You might not get 100% because I could have other issues, take some points off, but it's a good sign if you're getting green check marks for everything, you're getting all tests passed, including system tests, and you're getting like 100 out of 100 in the autograder. All right, well, so that's it for this video. So just to summarize kind of what we looked at here today. So we went through an example using this practice assignment of doing a complete workflow for doing assignments for the class. Okay, so some of the things that we covered, basically starting with accepting the GitHub Classroom invitation, and then once you have your repository created on GitHub, cloning your repository to your local system and getting that cloned repository opened up inside of a container so you have access to all of the development tools like the code formatter, the build test runners, and all that stuff should be set up for you for these the assignments. We gave you a few hints about using VS Code, how to access the tasks like the build system to build stuff. We went over making commits using VS Code, right? So the basic idea when you make a commit is, you have to look at your source control tab in VS Code, select only the files that have been modified that you want to add to the commit. So that's called staging the files for the commit. Once they're staged, you should make a commit message that follows best practices, so it has a title, and then a longer body of a description. And then you need to actually create the commit and push it up to GitHub. So I don't see it on GitHub until you've actually created it and successfully pushed it back up. Okay, and then it's important to know about the feedback pull request. That is what I see of your work mostly, and you can check what I'm seeing, and also I'll give feedback and stuff in your feedback pull request. I'll do code reviews there and other stuff. All right. So that's it. I hope that is all helpful for you. Good luck in the assignments for the course, and I hope to see you in class more.